All right, so first things first, if you have not seen it on Schoology, which a lot of times I will date my posts, you need headphones for class tomorrow. So you need to bring your earbuds. I will not be here. I'm going to be attending a funeral for a friend's mom. So I will not be here. It's all good. It's all good. She was an amazing lady. So funerals are a good time to celebrate somebody's life. They're not, you don't have to be like super sad things, whatever. Yeah. Celebrate the great things that somebody did. All because somebody passed away doesn't mean that their legacy is gone forever. You want to leave, when you leave the world, you want to leave the world a better place, right? So hopefully what you've done while you're here continues on long after you are no longer here. Because remember, our body's just a body. It's just a thing that we're in while we're here. So, bring headphones. I have a Chalk Talk. The Chalk Talk's already posted in Schoology. And what concerns me is there will be 1% of you, very few of you, maybe 1 or 2 of you, who are like, oh, I can work ahead. Yay! And then you're going to come to class tomorrow and have nothing to do. Please don't do the Chalk Talk yet. You don't have the notes yet. The sub will give them to you tomorrow because they're here. No, you cannot have the notes yet. So please leave it for class tomorrow. The Chalk Talk's only 20 minutes. So you will have time to do your homework after the Chalk Talk. So please leave tomorrow's work until tomorrow.
That sounds interesting.
Mr. Hudson.
Yeah.
On all of the chapters under the 6.3, 6.4 and stuff.
Yeah.
You have the notes under there.
They say 3. Or what? Or are you asking a question?
No, I'm just saying you have the notes under there. Couldn't we actually just print those out?
Yeah.
And do the notes.
Yeah, you could. That's why I'm asking.
Class?
Yeah, that's why I'm asking you not to, because otherwise you'll come here and have nothing to do tomorrow. But yeah, the notes are, in case you haven't realized it, because Solomon brought it up, the notes are all in the chapter folders. So if you go into chapter 6, you can access the notes. So if I go into 6.1, here's the notes. GN is guided notes. So you can always access all of that material.
Wouldn't that be used if you're absent?
Exactly. So, Jeremiah Smith. You already grabbed these notes, I guess, and put your name on it. I don't know. I'm confused, but for whatever reason, you already
the
have
wrong
these.
notes and he wrote his name on it, so then I passed him on.
Ah.
And then I gave him the right ones.
So, what is error? If we really talk about error, what is error?
Something went wrong.
What do you mean something went wrong?
It didn't work.
What didn't work? How would you know that you got an error?
If it's not correct, if it doesn't work.
Now, what do you mean not correct?
If it doesn't work, if it isn't right.
Okay, so again, you keep using synonyms, but I want you to define, not
If
use
society doesn't like what you do,
well, why wouldn't they like it?
I don't know.
It's not
They're
the same.
mean.
I don't know how it launched across, but it did.
Something that you don't want to happen.
Because it's
Something
different
that's
than what they think.
means opposite.
Something that's not supposed to.
So let's talk scientifically.
Something that's deviating
Hold up.
from the plan that said too bad.
Let's talk scientifically. Let's say we're running an experiment, and we are looking for a certain outcome. And you go to the restroom or something, you come back, and your friend's like, we had an error. How would you know that an error occurred?
Because that person just told you.
What if that person?
Okay, not calling on you, Andrew.
So, whatever you were testing, you look at whatever happened and look at all the information and data and see where it supposedly went wrong and calculated where it went wrong and how you can fix it.
How would you know that it went wrong? An outcome would... Honestly?
Okay, never mind.
That's all?
Be different from your original outcome and what you actually wanted.
So, we have a difference between what we have and what we actually wanted. Thank you very much for finally taking us there. So, percent error is dealing with what percent is that difference. How far away we are from where we were supposed to be or what we expected. That distance has a percent and we are going to compare this to the actual value. So the biggest mistake that people make, so I would highlight or star or something right now, the denominator. If you make a mistake in this section, I can almost guarantee it will come from your denominator. The denominator has to be the actual value that's observed. So the error is what the difference between what I see and what I expected or what I guessed or what I was hoping for compared to the actual that we see, and we have to divide by the actual. Now, the numerator has to be a positive number. So, who can remind us what those bars around this numerator is? Yeah, Dom?
Absolute value.
Absolute value. Question?
Why does it have to be a positive number?
Because percents, we don't talk about percents as negatives. We will say it's a percent greater or a percent lower, but we always talk about percents as positives.
Oh.
Yeah, because, so it can be higher or lower, but that would be just like comparative as opposed to percent has to be a positive amount.
And also, why is it the measured estimated value minus actual value and not the other way around?
But it could be the other way around. It could be actual minus measured. Because it's absolute value, order of subtraction doesn't matter. Yeah, so this could be flipped around the other way. So let's check out our launch here. We have our surly friend, and he comes back tomorrow too, but tomorrow he decides to start gardening. Your surly friend says that he wants to make 200 origamis. Now, we have Phoenix Fair coming up. Have you guys talked about Phoenix Fair at all?
No.
So for Phoenix Fair, you're going to be asked to start a business. And you don't actually have to do this, but you have to either do a mock business, like a fake one where you like just imagine all of it and write about it, or you can actually do it and actually make money. So my advice is actually do it.
When is
So,
this?
it's in November, I think.
Got a lemonade stand. That sounds awesome.
So, you set up a business and your goal is to make 200 origami animals so then you can sell them. But your sales total is 3% from your goal. So, if it's 3% from our goal, we can probably infer that we're below our goal.
Why?
But
Why can't it be like a
because otherwise we'd probably say above our goal if we but we're not certain. So, here's what we have to figure out. We need to figure out how many animals the group actually sold. So to do that, we first have to figure out, well, what is the error that we're talking about? Well, if our error is 3%, and error doesn't actually have to mean a mistake or something's wrong. It just means different from what I was hoping for, what I was expecting, or what I anticipated, or what I predicted, or whatever. It just means it's different.
Can I show you the process of how to find the amount of animals they sold?
Can I work through this way first? So, what we want to calculate, and yes, I know there are those of you thinking, okay, 97%, right? If we're 3% away, we know that 3% away from 100 is 97%. That's fine. We could use that method. But we want to talk about just the error. So to calculate the error in our sales, that's 3% of our total or of what we thought. So that's 3% of our 200. So our 3% becomes the decimal value, 0.3. Of becomes our multiplication, total 200. What would be 3% of 100? Jeremiah?
97?
What would be 3% of 100? Listen to the question asking. Acadia? 3. So 3% of 200 is 6.
Didn't sell 6?
No. That's the error. So, if that's the error, that's how far they are from the goal. So they were 6 short of making their goal. Or we could then say that they sold 194 because it's 6 short of their goal of 200.
Another way you could have done it was found 1% of 200 and then multiply.
Yeah, multiply by 3. Yep. A lot of right ways to get to Florida. So please make sure you have this written down. I am again about to forget to show our learning target. So by the way, our learning target, as you can probably infer, is I can calculate the percent error by first determining the difference in the values and then calculate the percent. Or in a situation like this, when we're given the percent, we can calculate the error, and then we can also use that to calculate what actually did happen. Any questions? Now, what if we look at this in a different way, though? Since it says we're 3% from the goal, do we actually know for certain that we were under the goal? No. So if we're 3% from the goal, they could also be 3% above the goal. So they could have potentially sold how many?
206.
They could have potentially sold 206 also, depending on how they're talking about the percent error. So error can go either direction. You could be under or you could be over. Our Burger King situation, you could get extra nuggets. That's an error. You could get not enough nuggets, and that's an error also.
Extra's a good thing, though.
Yeah,
So
come on.
if it can go either way, should we write both ways if we were to get a question like that?
We will normally tell you what direction it goes, but the thing about this situation is it doesn't. It just says from the goal. Now, because they say from as opposed to like 3% above the goal or surpassed the goal by 3%, we can probably guess that they didn't make the goal, but it's not actually really that clear here. And actually, I give you a problem on the homework that talks about like Mr. Kabila doing an experiment, and I think it's actually 3% also. I might be wrong. But so I tell you, there's actually two answers here. But of the possible answers I give you, only one of them makes sense. So it could be above or it could be below. You sometimes have to think about both situations. Because if you're running an experiment, let's say you're doing a reaction, and you put two liquids together, and it's going to react and make a solid, which can happen. And you expect a certain mass at the end. And you come back and your partner tells you, hey, we were 5% away from the expected mass. Well, is that away as in above or away as in below? You don't know. Now, if they said we're 5% above the expected mass, then you know which direction to travel. So be careful on that homework problem. So to calculate our percent error, this just shows you the process so that you have something to refer back to. Absolute value of the difference, which like Manasa said, if I turn this subtraction around, absolute value of 45 minus 36, it will get the same answer because of the absolute value. It'll always come out positive. And then we do the division, get your decimal answer, and convert it to the percent. Any questions on the process? Ozzy?
Why would you get 20%?
Because if I do 9 divided by 45, because this becomes positive, so this actually becomes 9 divided by 45, which if I divide them both by 9, it's actually 1/5 or 2/10, which comes out to be 20%. Biggest issue. There are actually 45 passengers. She estimates 36. The most common mistake is somebody would accidentally put 36 down here as opposed to 45. It's not your estimate that goes in the denominator. It's the actual. It's the observed, what is actually happening.
Are we not going to get the actual value, or are we not going to get the guessed amounts at any problem? Or,
What do you mean?
are we going to have to use a variable or find what they estimated or find what the actual value is?
Most of the homework that I give you, you have an estimate and an actual. You're comparing two values so you know very clearly. I think there's a couple problems where it says if the percent error is this percent, what was the amount of error or what could have been the outcome. But mainly we're calculating the percent. So try these on your own. We have estimated compared to actual. You want to make sure that your percent error, and if I was you, I'd write this off to the side to make it easy, is the amount of error, or really the easy way to say that is the difference divided by the actual. The difference between the values divided by the actual. I'll do one with you, I guess. So, I'm doing it with you, but it doesn't mean that you guys get off free pass. Samantha if I am calculating my percent error here and I want to calculate the difference, what subtraction am I going to do for A?
40 minus 45.
Yeah, 40 minus 45 or 45 minus 40. Order doesn't matter. So the difference between them becomes 5. I divide that by the actual. What's the actual? 45. This reduces to what fraction? 1/9, which we know repeats the numerator. We're going to round it and just say 11.1%. Try the other two on your own. You should only need about a minute. All right, Ashley, for part B, when you do that subtraction to find the difference between the actual and the estimate, what was the difference there? Yeah, 12, right? Because 75 minus 63, the difference is 12. And what do we divide by? What's the actual? 75. Now I can divide these both by 3 and get 4/25, which then I could multiply by 4 and get what, Julian? 6.3.
Wait, hold on. What was it?
Yeah, exactly. Because your head's on your desk and you're not watching what we're doing. So do you have any idea what I just said? So do you think that's a good decision? If I have 4/25, because I divided by 3 to reduce. But again, I don't want to use my calculator if I don't have to. How can I get this towards decimal form? What would I want in the denominator?
45.
Is there a decimal place called the 25th place?
Oh.
So can I turn 25 into a 10? Probably not. What's the next decimal place? Hundredths, right? Can I turn this into 100? Yeah. I just multiply by 4 and I get 16 hundredths, which then would become 16%. Anish, what about our difference in part C? What was your numerator for that situation?
I got 26.
26 for the difference divided by what's the actual? 99. And if it's stacked over 9s, it just repeats those digits. It will repeat the 26. So yeah, that decimal would go on forever. But if we round it, it'd be 26.3% approximately. Yeah.
How'd you get 26.3?
So this would be 0.26 forever. And then that would be 26.26. The 6 would round up the 2 to a 3.
Okay.
Does that make sense?
Yeah.
Any questions?
Wait.
Yeah.
So you just did the math to get 0.26 repeating?
What do you mean I just did the math? So I know that if we divide by 9 or any amount of 9s, it just repeats whatever's in the numerator as many as there are 9s. So since I have 2 in the numerator and 2 9s, it repeats the 26. So this works as long as it's proper. But if this was only 6, then I have to look at it as 0.6 to do the repetition, because I have to look at it as 2 digits. So, Noah, what division would I set up here in the got it?
You would do 250 minus 200.
250 minus 200. What would that be divided by?
200.
200, because we always divide by the actual amount. So that gives me 50 over 200, which can reduce
To 1/4.
Ooh, but don't go all the way.
Okay.
What's the easier thing to reduce it to?
25 and 100.
Yeah, because if I get to 25 hundredths, I know that that becomes the decimal 25 hundredths, and it becomes the percent 25%. Now, I'm going to show you the wrong way and how dangerous this is.
Do we write this down?
No. So right, like as long as you have this, you're good. The mistake people will make is they come along here and they say they're working fast, right? The issue comes from working too fast. And they say, okay, the difference between them is 50. He estimated 250. I have a fifth. That's 20%. Okay, move on.
No,
20% compared to 25%. This is why how you set up your work is so important. The error is not 20%. Because if what we were supposed to have, or what we thought we were going to have is 250, but what we actually have is 200, I'm 50 away from 200. Like my guess was 50 away from 200. My guess was 25% off. So be very careful to set that up correctly. We are going to have a contest. I just need to buy a bunch of Skittles. Where we guess, because then I use this in probability, you guess how many Skittles fit inside of a mason jar. And the winner, whoever's closest, I've yet to decide if we're going to play Price is Right rules, closest without going over. I normally don't. But whoever's closest wins the jar of Skittles.
Do you actually do that?
Yeah. Because then we look at statistical deviation of how far away were the guesses, and we can plot the data. Standard, like not the big ones, the normal small size. So we want to calculate, because this teacher is way nicer. This teacher is not going to just have one winner. They're going to let as many people win as possible. But they set that winners have to be within 5% of the actual amount. So you don't have to be the closest person, you just have to be within 5%. So there are actually 486 jelly beans in the jar. That's our actual, that's going to be our denominator. So for Jay, Sarah, Lisa, and Javier, we want to calculate what is their percent error. Are they a winner or not? Yeah, we don't love calling them losers.
I love them. But they are terrible.
They're losers.
But their guesses might not be as good. Now,
Lisa had the best.
hold up. Let's be strategic with this. I don't need to do
Strategy.
a ton of work. I don't need to calculate each of them. We can work smarter as opposed to working harder. Who's closest here? If there's actually 486. Lisa's pretty darn close. She's 11 away, right?
Yeah.
Javier's fairly close, a little bit more than 11. Sarah is probably the furthest away.
Yeah.
She's super far.
So let's start thinking about their error, their amount of error. Jay guessed 450, actual's 486. What's the amount of error there? 36, right? So jot that down somewhere. We have working numbers. 36 is Jay's error. 388 to 486.
That's nearly 100.
It's almost 100.
It's 90.
98, right? Lisa, 475 to 486, we actually already said this, was 11 away. And Javier, 15 away. So, as soon as we find that one of them goes over 5%, we know that if, like, let's say Javier loses, well, then there's no way Sarah could win and no way that Jay could win. So let's calculate Lisa's percent error and see, is she a winner at least? She's the closest. Now, the other trick with this teacher, if nobody's within 5%, nobody wins. So that's the flip side of this. If everybody's guesses are really bad, nobody might win. Or
You cheat and write a bunch of
it's possible that nobody would win. So Lisa's error is 11. So to calculate her percent, we would do 11. We divide by 486. Not her guess. It's the actual. 11 divided by 486. That is weird enough that we will use a calculator. Comes out to be approximately 2.3%. So is Lisa a winner?
Yes.
Yeah.
Lisa and Javier.
So, yeah, let's try Javier. Now, if we change this to an error of 15, that percentage becomes approximately 3.1, approximately. So Javier is also a winner.
Good job.
But now if we change this for, let's go, J is the next furthest away. So we do 36. Oh, Elena, thank you. You have a calculator. What do we get here? Or do you already have it, Whitney?
Oh, I just wanted.
Do you have a question?
No, I was just gonna say that there's no way he could win. Javier had 3% and it needed to be 5.
Ooh.
15 plus like 15. That's
Ooh.
half. That's not
Thank you. So Javier was 3% off, right? That came from being 15 off of the guess. J is more than twice of Javier's error. So, if J's error is more than twice of Javier's, his percentage will be more than twice. And that means that J lost, and so did Sarah. What's up, Ozzy?
Alright, I did 36 divided by 486, and I didn't get the same thing.
Well, we didn't even calculate it.
I need to calculate.
We never actually did this calculation. Like, I don't know what's here because Whitney stopped me and said we don't have to. Now we could.
But I got on the calculator I got 0.074.
Yeah. 0.074 becomes 7.4%. So they're over 5% away, which means they lost.
I get it now.
Does that make sense?
Wait, did you split
17 inches.
Would I what?
So like if in your Skittle thing, if 2 people had the same guess and they were like the winners, would you split the Skittles? Or would you do like
last year when I did this, I brought another mason jar. I just did 2 of them. Because 2 people were actually exactly as close as each other. One person was that far below the guess, and the other person was that far above. And I don't know how many Skittles are in the jar until after everyone guesses. So I have no bias when you guys are making your guesses. Like, I just dump them in and seal it. I do not count it. So to try to make it fair. Nope, not until after. Yeah, it makes it fair. Because otherwise I have a bias when you come up and guess, and you're like, hey, I think there's 180. And I'm like, meh. I don't want to have bias,
But how
right?
do you find the answer though?
I count them afterwards.
who won it last year?
Oh my gosh.
I forget. I'm sure they remember. I mean, it was 2 girls. Sean?
Do you get the little tiny packs or like the normal packs?
Of Skittles?
Yeah.
I get the Sam's Club bag.
Oh, God.
Like
that one.
pounds. Yeah. Except it's because my mother-in-law knows that I like Skittles, so she always buys me one of those like occasionally. Sometimes. We're talking way too much about Skittles. Try the got it on your own. The other trick. Sorry, Saul, I was interrupting you. You good?
No, I was interrupting you. Sorry.
Thanks. What's up?
I'm really going to interrupt.
Yeah.
Do you know what the hourglass means on the screen? When I'm trying to switch to camera.
So try this on your own, guys. Be careful with units. That's all I was going to say. Be careful with your units.
Sorry.
Wait. Shut your face out. Cyberbullying. Well, that channel's weak. Okay, I got it.
Do a bunch of stuff in front of the camera.
He was 5.6% over here.
Dom.
You can just hear what I'm saying. It's not facing.
Go.
You get to go to Weenie Hut Junior.
I love Weenie Hut Jr. Best episode SpongeBob.
Have you not seen the SpongeBob movie?
Love
You
SpongeBob.
have.
He's so loud.
No, you're meant to
Have you seen Korean in the House?
Gosh.
I don't even know what that is.
Like being anime is Korean house.
Here. I've only seen like one. One episode.
What's the actual in this got it?
18 inches.
So that's where you have to be careful. The actual is 18 inches. So the division you set up, what, Dom, is the numerator in this situation?
That would be what the weatherman predicted, which is 17 inches of snow.
Is the numerator?
Yeah.
No.
Oh, then I screwed this up.
And that's what I expected a lot of us would do.
Yeah.
Jeremiah, what was your numerator? Sorry, Smith.
Oh,
Smith.
Wait a minute.
Hey, Jeremiah Smith. Do you know what the numerator is? Okay, that's fine. You just weren't saying anything. Jeremiah Hahn.
Oh, okay. So I'm just gonna show you my work. I did 17 inches of snow minus 18 inches of snow, because that's what 1.5 feet is.
The estimate
subtract
minus
it
the actual.
Over 18 inches, because that's the total, and you get -1 over 18. Well,
What? Yeah, once we do the absolute.
but,
So
and then you get,
you're fine. Keep
and
going.
then you get, and then you get 0.056 because I rounded.
Well,
And then,
So then, if I convert,
and then if you convert, you get 5.6%. Oh.
approximately
Yeah.
5.6%. Because the numerator is not what the guess was, it's the difference. Elena?
I don't check something because how come for that one we did like the numerator, the guess minus the actual, and then for the Skittles problem we just did the guess.
This is not the guess. That's the difference between the guess and the actual. We just didn't show the subtraction. So remember, their guess, like Jay's guess was 450. But the difference between his guess and what actually happened was 36.
Oh yeah.
Does that make sense? So, the big thing with why is there an absolute value? Percents have to be positive. So, if you want to write that down, we already talked about that earlier today, but percents have to be positive. That is why we use the absolute value. So our dot plus shows the measurements made by a science class, and you guys will be doing this later in the year, like taking measurements, cataloging data, looking at everybody's measurements that they got, and comparing to the class. If the rock's actual mass is 1.1, what's the greatest percent error among the measurements? Well, how do you know that it's the greatest error? How do you calculate, or how do you know something is going to have the greatest error? Katia?
Kind of like the thing that's furthest away from the actual.
Furthest away from the actual. So if I know the actual is 1.1, which guess or which observation, which measurement, I guess, is furthest away?
0.
I have like 9 hands up and I was just deciding who. So actually, Whitney, can you walk me all the way through this? Which one's furthest away?
0.8.
Yeah, because if I look this way, I only have to travel 2/10. This way, we have to travel 3/10. So then, how do I calculate my percent?
1.1 minus 0.8.
So absolute value, 1.1 minus 0.8. Absolute value all over.
Over.
Yeah, put it over the actual.
Shouldn't it 1.1 and 0.8 be swapped instead?
It doesn't matter.
Absolute value.
So I always just do bigger number first because it's easier. So all you're doing is calculating the difference between them. It doesn't matter what the order is. So this becomes 3/10 over 1.1, which, guys, think about this like 3 over 11. Because I can, on the bottom and the top, like simplifying, I can multiply these by 10, and that's the same fraction. These are equivalent. So this really becomes 0. What? How do I figure it out when I divide by 11? I actually, Andrew,
Multiply by 9.
multiply by 9, so we get 0.27 repeating, which comes out to be
27.
approximately
That's the great
27.3%. Try the final got it on your own.
Are we still sticking why is there an absolute value in
No, this final on the bottom.
We're still sticking with the 1.1 thing?
Yeah, like it doesn't say what the correct.
Oh, sorry. Yeah, the situation in the lessons that I used to use, the Pearson things. Your actual here.
5.9?
Oh, wait, 5 point what?
What do you think the actual is?
5.9?
Mm-hmm.
Okay, cool.
The one with the greatest amount of observations. That's your actual.
Is the last one 7 point? Yeah, okay.
7.3 is the furthest out to the right. In case your print came out weird. So what is the percent error of the worst? What is measurement of the rock? Now this could have meant that their scale was off, or it could mean they don't know how to do what they're doing. Like I give you guys a problem on the homework where the thermometer itself is actually like off. It has error. And sometimes we have error in items, which is okay. There's an acceptable margin of error. But once you have too much error, then you'd like throw things away or replace it or fix it or something like that. Elena, are you able to walk me through this?
No.
No? Solomon, are you able to walk me through this?
No.
Samantha, are you able to walk me through this? So, what is the first thing that I'm going to do here?
You're gonna find the greatest percent error.
Yeah, so to find the greatest percent error, what's the first thing I think about?
Which one's farthest away?
Yeah, which one's furthest away? So is 5.1, which is a difference of 0.8, or 7.3, and I can tell just from my dot plot, the 7.3 is way further away. So to find that difference, I then just do the subtraction. And what do you get? 1.4. So now to calculate my percent error, what do I do with that?
You do 1.4 divided by 5.9.
So we already found our difference. We did it in a manner that got us a positive answer. So then I do my 1.4 divided by the actual amount. Go ahead.
I got 13.6.
Once I get my decimal and convert
It's like
to percent form,
13.55, but rounded.
rounded 13.6. Yeah?
Is that the way I should do it? Because what I did was, I did 5.9. Like I used 2 numbers at a time instead of like combining the numbers and subtracting them.
What do you mean?
Like I did 5.9 subtracted by 5.1 over 5.9, which I got 0.
Oh, you compared their percents? Yeah, that's fine, but you could also, so you can either compare before you start, and then just calculate 1%, or calculate both percentages and then compare the percentages.
Wait, isn't 1.4 divided by 5.9 2.3.2? 23.7.
Let me check this. See if somebody's calculations were off. Yeah, I get 0.237. Who gave me the value for
Oh
that?
wait a minute, I did the wrong one. The other one was.
Yeah, be careful. This actually comes out. Hey guys, change this. If you wrote down the wrong thing,
Yeah, my bad.
it's 27.3.
23.7.
Yeah, 23.7. Yay, dyslexic.
The other one, my bad.
All right, but your homework is up. Give it a shot. Bring headphones to class tomorrow. You will need them to watch the Chalk Talk. Thank you very much, guys. Have a great day.